Students, we are given this question: if y is equal to sine of 5 times sine inverse of x, and that we have 1 negative x squared times y3. y3 stands for the third derivative, and that is equal to lambda times x times y2, the second derivative, positive mu times y1, the first derivative. So this has to be achieved by us, given that the value for y, and from here we will have to extract lambda positive mu. So let's do this question. So foremost, what I would do is I would consider y to be equal to sine of 5 times sine inverse of x. Now this is a beautiful question, and it involves some tentative threading. So what I mean by that is that we need to be a little bit cautious in approaching this, because if you were to outrightly start differentiating this term first time, second time, third time, you will forever end up in obtaining the derivative. So there wouldn't be any termination at all. So hence it is imperative for us to adopt a way by which we can achieve the end result, lambda positive mu. So for that, foremost, let me just state here, differentiating with respect to x, we get, so this is going to be y1 is equal to differential of sine would give us cos of 5 times sine inverse of x. Differentiation of sine inverse of x is going to be 1 over root of 1 negative x squared. So this is fair enough. Now with our quantity sine inverse of x, we also have a constant 5, so we will have to place that constant 5. So what I'm going to do is I'm just going to place 5 there, because we are differentiating the entire quantity 5 times sine inverse of x. Though we might be tempted to negate the constant or take the constant out, but it is not advisable to do that. So what we have got here, this is equal to cos of 5 times sine inverse of x times 5 over square root of 1 negative x squared, and that is equal to y1. So now what I'm going to do is I'm going to push this y1, in other words I'm going to push this root of 1 negative x squared to the left. So that's going to be y1 times square root of 1 negative x squared is equal to 5 times of cos of 5 times of sine inverse of x. Now what I'm going to do next is I'm going to let 5 times of sine inverse of x be equal to some phi. So if I were to take this as 2, therefore I can rewrite 2 to be as y1 times root of 1 negative x squared is equal to 5 times cos of 5 times sine inverse of x is phi. So this is going to be cos phi. So probably it's better to write like this, cos phi. That's fine. So since I've taken 5 times sine inverse of x is equal to 5, you can see that the original equation, what is it given? I'm going to rewrite this over here. Given y is equal to sine of 5 times sine inverse of x. Now since 5 times sine inverse of x is equal to phi, hence I can now rewrite y to be as sine of phi, right? So that is a nice way that we have got our y. Now having obtained the y, let's go back to our system. So clearly we get y1 times root of 1 negative x squared is equal to 5 times cos phi. Now what I'm going to do is I'm going to rewrite this cos phi as square root of 1 negative sine squared phi. Now clearly we know that sine phi is y, so this is going to be 5 times root of 1 negative y squared. So from here this is going to be y1 times root of 1 negative x squared is equal to 5 times root of 1 negative y squared. So we have a beautiful system which is manageable. So now we will have to start off with our differentiation process. So before we could do that, clearly you can see that there is a presence of a square root there. I don't want to have that. So the best way, before we could start our differentiation, let us remove that. So I would be squaring both sides. So if I were to square both sides, this is going to be raised to the power of 2. This entire thing is raised to the power of 2. So this is going to give me y squared, y1 times 1 negative x squared, 5 squared, that's 25 times 1 negative y squared. So take some precaution when you're writing the indexes, because we are using an index and a suffix. So those two things should not be mixed up. So now let us start our differentiation. So differentiating with respect to x, we get, so this is uv. So I will start by placing the u. So that's going to be y suffix 1 squared of differentiation of 1 negative x squared. That's going to be negative 2 times x, followed by differentiation of this quantity. So let me place the 1 negative x squared, and this is going to be 2 times y1 times differentiation of this y1. That's going to give me y2. Now this is equal to 25 times differentiation of 1 is 0. Differentiation of negative y squared is going to be negative 2 times y times differentiation of y. That's going to be y1. So I have, clearly you can see that you have a 2 here, a 2 here, and a 2 here. So I can get rid of this 2, this 2, and this 2. And I have a y1 and a y1 and a y1. So I can get rid of that y1, y1, and y1. So what is left now? So I get a y1 now. Of course there is a x there, and there is a negative sign, fine, and followed by 1 negative x squared times y2 is equal to 25 times, you have a negative sign and a y. So this is the system that we have got. Now the first differentiation is finished, the second differentiation is finished, so we got y2, but we need to get y3. So differentiating with respect to x, we get, so we will have to differentiate this quantity. So in this case it's uv, so I'm going to take a negative sign out, so it's going to be y1, differentiation of x is 1, positive x times differentiation of this y1 would give me y2, so that's fair enough. This is uv, so it's going to be 1 negative x squared, differentiation of y2 is going to be y3, followed by y2 times differentiation of 1 is 0, negative x squared would give me negative 2x is equal to negative 25 times differentiation of y is going to be y1. So let us expand it and check out if anything can be cancelled. So this is going to be negative y1, negative x times y2, and positive 1 negative x squared y3, and this is negative 2 times x and y2 is equal to negative 25 times y1. Now negative 2 times x2, negative xy2, these two can be connected. So if I were to add them together, I would get negative 3 times x y2, and then I have y1 here. So let me place this, followed by 1 negative x squared times y3 is equal to negative 25 y1. So now we can actually club these two together, right? Negative 25 and negative y1. So what I'm going to do, I'm going to retain this 1 negative x squared times y3, and then I will place negative 3 times x y2. So now I will push this to the other side. So negative 25 y1 positive y1, which is going to give me negative 24 y1, and I've got 1 negative x squared times y3. Now what I will do, I will also push this negative 3 times x y2 to the other side. So that would give me positive 3 times x y2. Now if you were to compare the system, so let's go back and compare it to the given system. On the left hand side, 1 negative x squared times y3. So you see here, on the left hand side, 1 negative x squared times y3. So that has to be followed with lambda times x into y2. So lambda times x into y2. So we got x into y2 here. So I'm going to rewrite it like this: 3 times x into y2, and followed by positive of negative 24 times y1, and this is 1 negative x squared times y3. So let me rewrite the problem down. The problem is given to be as 1 negative x squared times y3 is equal to lambda times x into y2 plus mu times y1, and then they want us to find the value of lambda positive mu, what exactly this would be. Now if you were to compare this, so this is the original system, I'm taking this to be say sum 4, comparing 4 with 1, we get, so what do we get when you compare 4 with 1? Clearly this would mean that lambda is equal to 3 and mu is equal to negative 24. So this is what we have got. So from here, what is lambda positive mu? So therefore lambda added with mu is equal to, lambda is 3 and mu is negative 24. So this is going to give me negative 21. So this is a beautiful question, and this is the right place for us to box the result. Students.